All right, now that you have all of the skills and knowledge that you need for Venn diagrams, we're going to look pretty intensely at some problem solving with Venn diagrams. In this video, I'm just going to take 2 or 3 questions from your textbook. I'm looking at section G, page 225. I'm just going to walk you through how to solve these using Venn diagrams. So let's say, for example, our first one, we're going to use a 2-set Venn diagram, and we know that because, let's read through the problem, and I think you'll see or understand why. So a squash club, who knows what squash is, right? A squash club has 27 members. 19 of them have black hair, 14 have brown eyes, and 11 have both black hair and brown eyes. Well, it sounds kind of confusing. Let's start writing some numbers out first. So the total squash club, that's going to be our universal set. So the number of elements in U total is 27. Now, we need a couple of other sets here. Let's have, we said we have some people that have black hair, so let's let them be BL, and there are 19 of them. Number of elements in brown eyes, let's let them be BE, and there are 14 of them. And then number of elements in both of these, so this is going to be the intersection, a number of people that have both black hair and brown eyes is going to be 11. Now let's get a Venn diagram going here and see if we can fill in some missing information. So we know there's some overlap. These are not mutually exclusive sets. So here's U, and we said that it had 27 in it, so let's draw that. And here's black hair, and there were 19. I just like to put them in parentheses there so I can see exactly what I have going on. So here's BE for black eyes, and there are 14. And then right here in the middle, we know we have, this is the intersection. These are the people that have both black hair and brown eyes. There's 11 of them. Okay, so let's see what we can do. What information do we have? Well, we know that, let's represent our different areas here. Let's call this section A, we'll call this section B, and we'll call this section C, and then section D out here. So we know when we put all these together, A plus B plus C plus D, they told us earlier that the whole thing has to come out to equal 27, so we know that. And then we know that A plus B, so that's this and this, has to equal 19, because when we put these two together, so here's A, this thing, plus B, okay, that makes all of BL, and they told us earlier that BL was 19, so A plus B has to come out to be 19. Now let's come over here and let's do now B plus C. Here's B and C. Well, if you just think about it visually, everything, if we add everything that's in section B with everything in this section A, or C, excuse me, it's going to come out to be this whole section, which is BE, brown eyes. And they already told us earlier that brown eyes, there's 14 of them. So let's plug that in. So that's 14. And then they also told us this center section, they were pretty nice to us, and they said that B equals 11 people. Okay, well, how in the world does this, how does this help us out? Okay, well, let's think about it. We can translate a little bit here. And we already know what B is, so let's start plugging B in. If B is 11, then we can plug 11 in here and we can solve for A. So A plus 11 equals 19. Okay, take the next step. So we're going to do A equals 19 minus 11, which gives us that A equals 8. Well, we can try this. We can test it out, see if it works, because remember a plus b, or this whole thing, is supposed to equal 19, and it does. 8 plus 11 is 19, okay? So we're making progress. Now let's go here with b again and plug b in, and we get 11 plus c equals 14, and we go to the next step, and we're going to do c equals 14 minus 11. So c should come out to equal 3. And we can do the same thing. We can plug this back in and see if it works. Okay, 11 plus 3 would give us this whole circle here. And they already told us at the beginning that this circle is 14, and that's true because 11 plus 3 is in fact 14. Now, what is D? Well, let's see, we know all of the different pieces now, right? We know A, so we can come up here and plug A in, and that's 8. We also know B, so let's plug B in. B was 11, so 8 plus 11. And now we also know C, so we can plug in C. C is 3. And we don't know D yet, so we're going to try to solve for D. Here it is. So 8 plus 11 gives us 19, plus 3 gives us 22, plus D equals 27. And now we're going to bring this 22 over here, and we should find that D equals 5. And we can check this by plugging it back in to see if this is right. 8 plus 11 is 19. 19 plus 3 is 22. 22 plus 5 gives us 27. So we can plug in 5 down here for D. And now we're ready to go back and we're ready to answer some of these questions. So let's look at the question. We want to know how many or what number of members from the squash club have black hair or, keyword, or brown eyes. Remember I told you a while back that keyword or translates like this. So black hair, so we're looking for the number of elements in black hair or, which is union, brown eyes. So let's count it up. Well, all of these people over here, they have black hair or brown eyes. They happen to only have black hair, but that's fine. That's black hair or brown eyes. So there's 8. And these people here in the middle, how about them? Well, they have black hair or brown eyes. They just happen to have both. So let's add them in. And then these people out here, they also have black hair or brown eyes. It's just they happen to only have brown eyes. So this is plus 3. What about these people out here? These 5, well, they don't have anything. They don't have black hair or brown eyes. Maybe, I don't know, maybe they have red hair or something. But so now we're ready. We can go ahead and add these up. And this should be our total number. So it's 19 plus 3, which equals 22. So the correct answer for people that have black hair or brown eyes should be, there's a very sloppy 2 there, so it should be 22 total members. Okay, and the last piece of this problem, and then we'll pause, is we want to know how many members have black hair but not brown eyes. Well, let's look at this. These are all of the people who have black hair. The only problem is, out of all of these people, some of them also have brown eyes, and those are the ones we want to eliminate. So let's see if we can represent by shading these people right here in this little football. They're the ones that also have brown eyes because, remember, here's our set of people that have brown eyes. So everything in here, these people have black hair and brown eyes. So we want to eliminate those people. We aren't including them. How many people have just black hair and not brown eyes, well, it would be these people right here. Now, the way that we would write this, how would we write this? So we're going to write the number of people who have black hair intersect, not brown eyes. If we can think about that. So here are all the people that have, let me get a different color so you can see. Here are all the people that have brown eyes. So everything outside of that would be, all of this would be the people that don't have brown eyes, okay? And then we want to know, where does that, these people don't have brown eyes, so where does that intersect with the people who have black hair? Well, it intersects right here. So these are the people we're looking for who are not in brown eyes, but are in black hair. So this is them. And, well, I've scribbled it out now so you can't see it very well, but this was 8 members.